Hello once again. So here's another equation for our case 1 of higher order differential equation with linear homogeneous differential equation with constant coefficients of distinct real roots. Okay, so let's solve the general solution for this given DE. And as you can see, this is already in the form of differential operator. Okay, so the next step is for us to convert this into an auxiliary equation. So we have m cubed minus 3m squared minus 10m is equal to 0. Okay, so since the operator D is used, we cannot see the other variable aside from this y. Okay, so let's say the other variable used, or say the independent variable is x. So let's use independent variable x. Okay. Okay. So going back, we have m cubed minus 3m squared minus 10m is equal to 0. So let's find the roots. Find the roots. Okay, so since we have m raised to 3 here, so we need to find 3 roots. Okay, so first, since they are in m and 3m minus 10m. So the common is m, so let's factor out m. So what we have here is m multiplied by m squared minus 3m minus 10, right? Is equal to 0. Then to simplify it further, you need to factor out this term. So we have m, then we have m. So we need negative times, we have negative 5 and negative plus and plus 2. Okay, so if we multiply this negative 5 plus 2, we have negative 10 here, and negative 5 plus 2 is we have negative 3 here. So then it is equal to 0. Okay, so then let's equate these terms one by one into 0. So of course we have m is equal to 0, and then next we have m minus 5 is equal to 0, or just m is equal to 5. Then lastly we have m plus 2 is equal to 0, or we have m is equal to negative 2. Okay, so as you can see, since we have distinct roots, so we have 0, 5, and negative 2. They are distinct or different from each other. So we can use the case 1, or say we are under case 1. Okay? So in writing, since uh, among these three, negative 2 is the lowest, so we will use this from negative 2, 0, and 5 as this M1, M2, and M3, and so on. So we have, therefore, our general solution is y is equal to c sub 1. Then this form E, our m sub 1 is this one. This is our m sub 1. We have negative 2x, and then plus another constant c sub 2, E raised to power m sub 2, 0, 0x plus c sub 3, and then our uh, root 5x. Okay, so therefore we have y is equal to c sub 1 e negative 2x plus, since we have 0x here and e raised to 0, this is just equal to 1. Okay, and then plus c sub 3 5x. So therefore, if we simplify this, we have c sub 1 e negative 2x plus c sub 2 plus c sub 3 raised to 5x. So this is now our general solution. Sorry. Okay. Okay, so let us review our case 1. If we have a distinct real roots, okay, so from this equation we have a cubed minus 3d squared minus 10d. We transform it into auxiliary equation in terms of m. So we have this auxiliary equation now. And then we find the roots, and we have uh, here three distinct roots: negative 2, 0, and 5. And we use that distinct roots, negative 2, 0, and 5, as our roots in our general solution for case 1. So since we have these three distinct roots, so c sub 1 e raised to negative 2x, and then 0x, and then 5x. Okay, and then we cancel that out and simplify and get the general solution. Okay.